Okay, so now that we have it running locally, we need to go through all the understand how we could deploy this on a server inside of AWS. And again, it's different set of credentials, so I need to tell you all the background you need to know about the EC2s, how to launch them, how to get the credentials so that the application can work when we launch it on an EC2 instance. So before you launch an EC2 instance, there's some prerequisites that you need to have. The first is a VPC, which stands for Virtual Private Cloud. You have to have a private network already established on AWS before you can launch an EC2 instance. And when you launch an instance, you have to say in what particular subnet you want the instance to go into. Now, we didn't always have VPCs. Those came much later. And so there is something that you might run into with a customer who's been on AWS for a long time. You may actually see EC2 instances that are running outside of a VPC. That is no longer supported for new accounts, but if you have an older account, which is basically legacy, there's something they call EC2 Classics, which are EC2 instances that are running in one giant virtual public network. Now, for security purposes, that's not what we recommend. We recommend you put everything in your own virtual private network, VPC, and so new EC2 instances have to be launched into a VPC unless you have one of those legacy accounts. In that case, they let you still launch EC2 Classics, but again, you never want to be doing that. You don't want your customers doing that, and you want to make sure that if they still have any of those EC2 Classics, they have a plan to migrate those into a VPC fairly soon. Okay, so a VPC, this is our private network now. VPCs are isolated from other networks by default. Okay, so when you create a VPC, it's totally isolated. Now you create a VPC by giving it a IP address range known as a CIDR block. So you basically say, okay, this is my starting IP address, and I want it to have 1,024 addresses or however many addresses I want it to have. Then you divide your VPC into subnets. Every VPC has to have at least one subnet, and that's because an EC2 instance must be launched into a subnet, so you have to have at least one. But it's commonly to have two or more subnets in a VPC. You may choose to have a subnet for different types of servers. For example, you may have a database subnet. You may have a web server subnet, things like that. But it's also common just to have what we call private subnets and public subnets. And the difference is that a public subnet is for EC2 instances that are going to have public IP addresses and be reachable directly from the internet, where private subnets are for instances that are not going to have a public IP address and not be directly reachable from the internet. Now, there's no switch to mark a subnet public or private. Basically, the way you do it is with the route table associated with each subnet. So each subnet has a route table, and if the route table has a path to the internet going through what's called an internet gateway, then that means it's a public subnet. If there is no route to the internet gateway going out to the internet, then we call that a private subnet. And so that's the way you make it public or private. Now, speaking of gateways, your VPC has no gateways attached to it when you first create it. Without a gateway, there's no way traffic can get into your VPC. So there's two types of gateways. There's the internet gateways and the virtual private gateways. Internet gateways are for attaching the internet to your VPC, and virtual private gateways are for attaching a connection to your data center, so a private connection like a VPN. In addition, we need to configure security groups. So our EC2 instances have to have a set of firewalls protecting them known as a security group, and I'll show you how to create that in a demonstration coming up. Okay, so besides having the VPC, you also have to have an Amazon machine image in order to launch an EC2 instance. Now, the machine image is just a snapshot of the files that are going to go onto the boot volume for the instance. And so you have to pick an AMI to start with. Now, if you're new to AWS, you wouldn't have created your own AMIs. You're just going to use one of the ones provided by AWS or a third-party software company, and these are going to have the operating system for your instance, plus any other applications that may come pre-installed. Then finally, you're going to need something called a key pair. In order to log in to your EC2 instance, like if it's a Linux, you're going to have to SSH to it, or if it's a Windows, RDP to it. In order to do that, Amazon secures that with something called a key pair. So you're going to have a key pair created either beforehand or as you're creating the instance that's going to be used to be able to give you permissions to log into the instance. And again, I'm going to demo that in a little bit. Okay, so the virtual private cloud, this again a slide I borrowed from the previous presentation, is your private network space on AWS. You have to attach either an internet gateway or virtual private gateway, but there is none by default, but you'll have to have at least one of these in order to be able to grant access for traffic coming in and out of the VPC. So you'll have to put a virtual private gateway, say if you're going to be connecting your administrators from locations like your offices or your data centers or things like that. And you can set up a VPN connection or something called Direct Connect, which is a virtual private optic, which is a private fiber optic connection from your data center to AWS. Okay. And as I said, each VPC has to have subnets. Each subnet would have a route table that determines whether it's going to have a route to, say, the internet or back to your data centers through a virtual private gateway, etc. Okay, and then an option besides having private and public route tables is to also have network access control lists, or abbreviated NACLs. Now, this is another way of securing traffic inside of your VPC. You can define rules that allow and deny traffic into and out of subnets in something called NACLs. These are generally optional because we're also going to have firewalls surrounding the instances, but it's considered a second layer of defense, basically a backup to security groups to also have rules that control traffic at the subnet boundary layer. All right, so here's a diagram that kind of shows you some very simple VPC. You can see it's actually got two connections here. We've got an internet gateway, right? And this internet gateway is allowing traffic to and from the internet. And then we've got a VPN gateway, which is allowing traffic to and from our data center. So in our data center, we're going to have a customer gateway device. A whole list of compatible ones is in the AWS documentation. And with this customer gateway and the VPN gateway, we can make what's called a hardware VPN connection. So this is going to be using IPsec security. So even though it sends traffic over the internet, it's very, very secure with authentication protocols, encryption protocols, etc., all through IPsec. In addition to the hardware VPN, you could also have a fiber optic connection installed. As I said, that's called Direct Connect, where you can do the same thing, but basically not go over the internet and just go over your private fiber optic connection. Okay, back here in the VPC, we see that we've got a VPC, and inside of that, we're using a subnet in availability zone A. So just as a reminder what availability zones are, every region has at least 2 of these. Some regions have up to 5. A lot of them will have 3. 3 is also a common number. Now what these are data center clusters that are 20 to 40 miles apart from one another. Okay, and they're designed for disaster. In the case of a natural disaster, they don't all come down. So what you want to do when you launch your instances later, I'll show you, is you want to leverage more than one of these, so that you don't have single points of failure in case there's an availability zone outage, like a tornado hits one or something like that. It doesn't take down everything. Okay, now in your availability zone, you're going to create a subnet. Again, every VPC would have to have one per availability zone that you're going to use. And then you launch an instance into the subnet. Now, the subnet is going to have a route table that determines whether it has a path out to the internet, or sorry, I didn't mean to do that, or whether it has a path out to the internet, or whether it has just a path out to the VPN gateway, or both. Okay, so the way we protect our instances with firewalls is something called security groups. Okay, and a security group surrounds your instance, and it controls what protocols are allowed to enter your instance. You can see in my diagram here that I'm allowing HTTP in the security group, but I'm blocking ICMP. Well, it turns out that this is an allow only type of thing. So everything is implicitly denied. So if I don't explicitly allow ICMP or UDMP or whatever it might be, or particular port, if I don't explicitly allow it, it's not going to be allowed. So in this case, I have to have a rule in my security group that would say HTTP, which is same as TCP port 80, and I have to also say a source and destination. So if say this is a web instance, like what we're going to do in our demo, I would want to put a rule in my security group that says I'm allowing HTTP port 80 from the whole internet, right? And so you have to create a rule for that. Now, with security groups, you can define inbound and outbound rule both. And so it kind of makes sense that I'm going to have an outbound rule too, but not necessarily, because there's a couple weird things about security groups. One is that they're stateful. So if I just allow, say, inbound HTTP into the security group, it's going to be automatically allowed outbound, okay? The other thing that's kind of weird about security groups, they allow you to set outbound rules, but by default, all the protocols and ports are wide open outbound, okay? You can change that if you want, but by default, there's no reason to mess with outbound rules. Now, security groups are something that can be shared in across a whole bunch of instances. So let's say that I want to create one security group and I want to call it my public web security group. I could use that on all my web instances. I don't have to create one each time I'm going to launch an EC2 instance. And the security groups are actually processed at the network interface level to the instances. So each instance has something called an ENI, which stands for Elastic Network Interface, and the rules are processed right at the ENI level to determine whether or not that traffic is going to be allowed. And you can have more than one security group around your instance. So one thing you might do, for example, is I might have a security group, it's called Public Web Security Group with HTTP port 80, but then I might also have an admin security group that allows SSH or something like that, and maybe a separate security group for that, so I would add both security groups to this particular instance.